All right, so we're going to go over questions number 9, 11, and then 17 and 18 on this. So for number 9, for all these, for number 9 through 14, when you're doing this, you should have your reference sheet next to you. So what you would do then is you would look and say, okay, the square root of 268. So I'm due to work over here off to the side. So we're looking to approximate the square root of 268. And the first step is to find out, well, what perfect squares does this fall in between? So then we go over here, and 268 falls in between 256 and 289. So I'm going to go back to my sheet, and I'll do 256 was the one, and then the other one was 289. Right, so square root of 289. And we know then that the square root of 289 is 17 based on our reference sheet, and the square root of 256 is 16. So since this number falls in between 256 and 289, that means it's going to answer will be 16 point something. All right, and we're going to round it to the nearest tenth. For this one, I'm going to use I'm going to create a number line and find out the middle number, and then this is approximate from there. So here, if we have our number line, we have 256. And here we have 289. So we need to figure out, well, what number is perfectly in the middle between those two in order for us to then be able to figure out where does 268 fall closer to. So we can then do 289 minus 256, which is then going to give me 33. And we divide it by 2 because we're cutting in half, and that gives me 16.5. So to figure out that middle value, we can add 16.5 to 256, which is then going to give me 272.5. So 272.5 is the number directly in half. So that means that this would be 16.5 as our square root if we were to take that. All right, and then we look and say, well, 268 falls to the left of this. So then I know that 268 has got to be, the square root of 268 has got to be less than 16.5 since it falls on the left side of that midpoint number. And then from here, I'm going to say, okay, well, which one is it coming? I'm just going to approximate this because that's all we're doing. So 268, it's only 4.5 away from that midpoint, and it's 12 away from 16. So that means it's much closer to that 16.5 than it is to that 16. So I'm just going to take a guess of 16.4. All right, we are just approximating it. Showing me your work here like this allows me to see your thinking and allows me to see that we are taking an educated guess. I know it's roughly 3 times further away from that 16 than it is to that 16.5. So maybe from here you might think about it as that as well, like this is 3 4s. So you might think, okay, every 4 could be 0.1. So that could also get us to that 0.4, or maybe you're guessing 0.3 for that. But it's your call of how you're just kind of guesstimating this. But it's an educated guess based on the fact that we know that it's less than half of that, so we know it has to be less than 16.5. And then since I was doing this, it's way closer to 16.5 than it is to 16. I'm just taking that guess of 16.4. Right, and then the actual value for that, if we were to take the square root of 268, is 16.37, which does round to 16.4. So our guess was really close to what it was. And if you were to guess 16.3 as well, you would be credit for that. Just 16.5 would not work as an answer. All right, so then for this next one, it's a square root of negative square root of 77. So I'm just going to real quick write negative here, so that way I don't forget about the negative sign, and then I'm just going to disregard that negative and just treat it like it's a square root of 77. And then since I already reminded myself I need to put the negative at the end, my answer's already got it built in. So I'm looking and say, okay, well, where does 77 fall in between? Well, it falls in between the square root of 81 and the square root of 64. Square root of 81 we know is 9. The square root of 64 we know is 8. So we know that this answer then is going to be 8 point something. Now we know it's going to be negative 8 point something, which is why we put that negative to begin with. And now we don't have to worry about that again. All right, so now we're going to use the other method that we talked about, which is then creating a fraction and see, well, what percentage of this number is in between those two. And we can do that by subtracting that middle number from the number we're looking at from the smallest one, so that's 13. And then we take the range of the two numbers, so 81 minus 64, which is then 17. So then we create the fraction of 13 over 17. And this is awfully close. What I would then do then is think about this as 13 over 16. And one of the numbers here that's close to this is I know it's going to then be roughly more than 3/4 of it, because 12 out of 16 will be 3/4. So this is roughly more than, let's just say 0.77 is my guess of this. And once again, how you come up with these guesses, they're all educated guesses. I know 12 over 16 is equal to 3/4, which is equal to 0.75. Since 13 is one more of those, I know it's going to be more than that. So then I'm just guessing that 13 over 16 is roughly 0.77. All right, now remember, we're going to write our two fractions, 13 out of 17 and 13 out of 16, and we're going to say, well, which one's actually greater? Well, since the number that we're looking at, 13, is the same, but this 13 out of 16 is more out of the total, we know that this is going to be greater. So if we guess this as 0.77, and we know that the 13 out of 17 has got to be less than, maybe I'm just going to guess this then as 0.74. I'm just making a guess. Since I know it's not perfectly 0.75, I'm just going a little bit less than that. All right, but then this would round to 0.7. So 13 out of 17 is roughly 0.7. So my guess would then be that this will be negative 8.7. All right, once again, they're just educated guesses, and we're just approximating what it is. You do not have to be exact. It's just approximating. And then the square root of 77 is 8.77, which would round to 8.8. So but you see that we are still awfully close to what the real square root is. All right, so that's how you can go about the two different methods that we learned for that. But ultimately, when you are answering those questions, to show me your work is very important, because your answer needs to be like an educated guess. So you're just showing me how you're coming up with, is it more or less than that 0.5? We learned that we can then cut that portion of our number line in half again to know if it's going to be more or less than 0.25. So there's different ways you can go about doing it, but it's all about making that educated guess. All right, so for this next one, we're converting a terminating decimal into a fraction. So for this, first thing we need to do is just figure out where's our decimal end. So it's the tenths, the hundredths. So this is saying 16 hundredths, so it's 16 out of 100. All right, but we cannot leave our fractions unsimplified. And if you don't know the largest number that goes directly into it, well, right now, we know that they're both even, so I know they're both divisible by 2. So this will then give me 8 out of 50. Once again, they're both even again, so I know that they're both divisible by 2 again. This will then give me 4 out of 25, and that will be our final answer. Both of these were divisible by 4. If you knew that right away, you could just jump straight to the answer, but just showing you, I'm always going to go through smaller by smaller while we're doing this, just to show you it doesn't really matter if you can see it right away or not, because once we then just simplify once, just look and see, can it continue to go again? And it's easy to know that things are divisible by 2 because they are even. All right, then the last one I'm going to go in this video is this question number 18. Now this is when we're converting non-terminating decimals. So the bar tells us that this is 0.181818 and so on. And then when we have 3535 ... we see it's repeating at 35. So we could also have rewritten this as 0.35 with the bar over top. I'm just showing you different ways we can do it. First step is kind of like the other one. We look and see, where does this pattern, like when does it repeat, when does it end, and what point of our place value is that? So we're always looking at place values. And here we see it's the tenths, the hundredths, where it's going to start repeating again. So what we're doing then is we're taking this number and we need to manipulate it. We need to move out the whole, because we want to turn it into a fraction, so we need to get a whole number here. And what we're going to do then is we multiply by how long it takes for it to repeat. So I'm multiplying it by 100 because that's its place value, where it stop, like where it's decimal goes and ends in its repetition. So then by multiplying by 100, we now get 18.181818 and so on. All right, so now this 0.18 represented our initial problem. And if you thought about, like when we talked about like how many pizzas we have, if we have 0.18 of a pizza remaining, like this represented one pizza pie. Well, when we multiply it by 100, this value actually now represents 100 pizzas. But what we need to do is we need to get rid of the decimals, right? We don't want to have those decimals anymore. We only want to focus on the whole numbers. So what we do then is, now we're going to get rid of the original problem, the original decimal, which is 0.181818 ... Since we know that these are all repeating at the same rate, when we line them up, they're all going to line up perfectly. So when we subtract, they're actually going to get rid of all of our decimals. So we're going to subtract this, and our decimals will actually cancel out, and now we're just left with 18 as a whole number. Now this is where it gets a little tricky. Well, we had 100 of these pies, pizza pies. That's how we got the number 18.188 repeating. And we subtracted one of those pizza pies out because we subtracted one of our original decimals out. And this represents the number, like one of our fractions, 0.18. So when we subtracted that, we need to think about how many pizzas we have left. We have 100 after we multiplied it by 100, and we've removed one pizza from it. So now we have 99 pizzas remaining. So what we do is we take these two values, the number that we got after we removed our repeating decimal, and the number that represented our total amount after we manipulate it by multiplying by that 100, and we create a fraction. It becomes 18 over 99. And then the same thing is we just look to simplify. Well, one of the rules we learned is when we add our values together, and if that's divisible by 3, the whole thing's divisible by 3. So I know both these numbers are divisible by 3. So then give me 6 over 33. And once again, I know 6 and 33 are both divisible by 3, so I'll divide each of these by 3, and that gives me 2 over 11. And 2 over 11 will give me the repeating decimal of 0.18 repeating. All right, for this one, it's really just, you just have to just kind of practice it. It's the same steps over and over again, and understanding how we generate the denominator can be a little tricky, but the more you do it, the more you practice it, the more we'll start to realize, okay, like it's kind of just following these steps. We're trying to create two different values of how many we have. That's the 18 versus the total amount to get to that, which is that 99.